Everyone, in this video we're going to go through your fractions test revision. So breaking down all the success criteria at the start of each section. So you can see here we're looking at recognizing equivalence and fraction size and what you need to know underneath that that main success criteria. So these questions do cover that, and they will be similar to what you'll see on your test revision. So as we work through this sheet, I encourage you to pause at any time and have a go at the questions. I'm not going to do every single question because I'm sure you don't want to listen to me for probably 2 hours. So I'll do just a little bit from each question, but please make sure you're actually doing it on your own as well. All right, so question number 1, circle the fractions that are equivalent to 2/3. So before we look at what's equivalent to 2/3, let's just have a look at fractions that are equivalent. So instead of, answering the question, let's just have a look at equivalent ones. So with the 2/3, basically, I can multiply my numerator, actually I want a different color, my numerator and my denominator by any number other than 1. So if I multiplied it by 1, I'm going to have the same fraction. So any number greater than 1. So if I multiplied it by 2, then that's going to give me 4/6, which is the same fraction. I could take 2/3 and multiply my numerator and my denominator by 3. So remember, if you're doing equivalent fractions, you must do the same to the top as you do to the bottom. So 2 times 3 is 6 and 3 times 3 is 9. And you can use that understanding to circle the fractions that are equivalent to 2/3. So let's have a look at each one. So 3/4, no. 4/6, we just did that one, so that's good. All right, I'm going to just circle that one. Now I've got 6/8, so to get the 6 from the 2, I would multiply by 3. And remember, whatever I do to the top, I've got to do to the bottom. So that would actually give me 6/9. And you can see we did that over on the side here. So 6/8 is not equivalent. 2/10, well, you can't just change the denominator. 8/12, so let's go back. What did we do to the top to get to the 8? We multiply by 4 and multiply the 3 by 4, and I actually get 8/12. So that's another equivalent fraction. There's the 6/9, which we did before, which is awesome. All right, the next one, what did I multiply the 2 by to get to 20? I multiplied it by 10, so I've got to do the same to the bottom. Fantastic, that's 20/30, so that's another equivalent fraction. All right, let's just keep going. Now 4/5, we already know that 4/6 is one of the options, so you can't have 4/5. 14, what did I multiply the top by? I multiplied it by 7, so I've got to do the same to the bottom, so 14/21. And then 9/18 I know is a half, so and also I can't multiply 2 by another whole number to get 9, so 9/18 is not an equivalent fraction. All right, I'm just going to delete all that because I want to use these as my solutions. Okay, but that's they're equivalent fractions. All right, they all equal exactly the same thing. They're just like the same fraction, just wearing a little bit different makeup or a different outfit, but exactly the same fraction. All right, question number 2. Now we've got to make these these equations true. So remember, we always draw our arrow to the unknown. So if you get questions like this and you like to do a little bit of, things in order, you can just point your arrow for all of them to the blank spot. All right, because that's what we want to find out. All right, so I'm just pointing the arrow to the blank spot. Now with each question, you've got to, whatever you do to the top, you've got to do to the bottom. So just making sure your arrow is pointing the same direction for each of them. So you can go through and do that if you like. All right, so I'm not going to keep doing them because the video will go on forever. So we'll just do a few of them together. All right, looking back at question A. So I say, well, what did I multiply 1 by to get to 2? All right, and remember, you're not always going to be multiplying. You could be dividing. So if you're going from a small number to a big number, you're multiplying. If you're going from a bigger number to a smaller number, you are dividing. So in this case, we are multiplying because we're going from 1 to 2. So whatever I do to the top, I've got to do to the bottom. So 1/2 is the same as 2/4. Let's have a look at question B. So this time I'm going from 20 to 10, so I'm going smaller. So I divide by 2. All right, so 20 divided by 2 gives me 10, and then I do the same to the top. So 6 divided by 2 is 3. So 6 over 20 is the same as 3/10. All right, and we go through and do the next one. So for C, we're going from 33 to 3. So I'm going to divide by 11. And whatever I do to the bottom, I've got to do to the top. So 11 over 33 is the same as 1/3. All right, let's have a look at D. So I didn't add the arrow, let's put it there. So what did I do to get from 21 to 7? I've got to divide by 3, and I've got to do the same to the top. So 6 over 21 is the same as 2/7. Now you'll notice with all of them, I do the same thing to the top as I do to the bottom. That is what equivalent fractions are. Okay, so you're kind of making it either bigger or smaller. You make your numerator and your denominators bigger or smaller, but the actual fraction itself stays the same. All right, so the portion that you have stays the same. And you could always think of a pizza. You know, if you and your mate went and bought a vegetarian pizza and the pizza guy cut it into 8 pieces. All right, so let's just quickly draw the pizza. So you got your pizza cut into 8 pieces, and there's only you and your friend, and you said, all right, let's get half each. So I've just highlighted half of the pizza, but you can see that's the same as 4/8. All right, so I've got 4 pieces and the whole pizza is being cut up into 8 pieces. All right, so they're equivalent fractions. All right, so you can go on and finish those questions. All right, so I did just pause that and did the answers there. So if you didn't already pause it, perhaps pause it, have a go at finishing them off, and you can have a and then you can check your answers. Now I noticed they're all going from bigger to smaller. The first one was the only one where we multiplied, but I think in class we did quite a few of both. So hopefully you understand that if you're going from a big number to a small number, you divide, and when you're going from a small number to a big number, you multiply. And the direction doesn't matter. So just make sure you use your arrows just so you don't get it confused. All right, question 3, we're writing the fractions in their simplest form. So simplest form just means that, you know, if we're making comparisons with, say, a population of people. So let's say we're taking 150 students in year 7 and 50 of them play netball on the weekend. All right, so that means we've got 50 over 150. Now, basically, that's okay to say, but it's a lot easier to say, all right, that means that 1/3 of the students in year 7 play netball. Okay, so if I picked out 3 students, there's probably one of those students who played netball. Okay, so 1 in 3. All right, so that's why we would simplify fractions, because it's just easier when we're explaining things to picture what 1/3 would be as opposed to 50 over 150. Now, to simplify fractions, we look for the highest common factor. Now, always take the smallest number first. So we often deal with proper fractions. So when we're looking at all these fractions, they're all proper fractions. So the smallest number is going to be on the top. So I just need to think of factors of 6. So a factor is a number that divides into 6. Okay, so I'm just going to write them here. So we have 1 and 6, they're a factor pair, and 2 and 3. Now we've got to only focus on these numbers for 12. I don't have to write all the factors of 12 because clearly they all won't also be a factor of 6. So I only need to think of factors of 6. Now 1 clearly goes into 12, but I wouldn't divide by 1 because then I get the same fraction. 6 goes into 12, so does 2 and so does 3. So the highest common factor is 6. So that means to simplify, because remember to make it smaller, we want to divide. So I'm going to divide the top by 6, divide the bottom by 6. So 6 divided by 6 gives me 1, and 12 divided by 6 gives me, whoop, not 12, oops, gives me 2. All right, I was a little bit unfocused there. So 1/2 is the same as 6 over 12. Now you do get fractions that are a little bit harder to think of what the factors are. So you could simplify it by using a common factor as opposed to the highest common factor. So if we look at B, you might think, oh, I don't know. So instead of sitting there for a few minutes thinking of what the highest common factor is or writing them all out, all you need is a common factor. And we can see they're both even numbers. So I can say, well, let's just divide them both by 2. See if that makes it a little bit easier for me. So 16 divided by 2 is 8, and 48 divided by 2 is 24. You're like, oh, okay, well, they're still both even numbers. So that means I can probably divide them by 2 again. And I get 4 over 12. Oh, I can see. Now 4 I know also goes into 12, so I could do that. And you can get your simplest fraction that way. Now it is a longer way to do it, but when you think about it, you could be sitting there thinking of the highest common factor of 16 and 48, and that might actually take you longer. So if you can think of a factor, just do it with that factor and then keep simplifying from there. All right, so just because I want these as my final answers, let's actually think about what the highest factor is, and it is 16. So it is a high one. Okay, but remember, you just need to simplify. So you could get 1/3 that way. All right, so for question C, thinking of the number 9, factors of 9, we have 1 and 9 and 3. Because 3 times 3 gives you 9. Now 9 doesn't go into 33. 1 we don't want to do because it's just going to stay the same. So it's 3. 3 goes into 9 and 3 goes into 33. So I'm going to divide the top by 3 and divide the bottom by 3. So I get 3 over 11. All right, so I'm going to pause now and do the rest of the answers. So it might be a good idea for you to pause as well, and then you can see the answers and see how you go. All right, so just on the answers, and you will notice, quite interestingly, that we've got 3 here that are all equal to 1/3. So you can see we've got equivalent fractions in question 3. We're simplifying them, and we can see that they're all equivalent, all equal to 1/3, which is pretty cool. Did not do that intentionally. And some of them are quite difficult. So 24 over 72 and 32 over 96. Remember, all you need is a common factor if you can't find the highest common factor. All right, but just keep going until you are confident it's in its simplest form. All right, let's move on. Okay, so question number 4, circle the fraction that is the largest. So when you're comparing fractions, it's easier to have the same denominator, but you don't always have to change it, and I'll show you why when we're going through them, so it just might make it a little bit quicker for you. Now the first one, we've got 3/4 and 1/4. So if I just do a quick diagram, all right, so we've got splitting this into quarters and comparing it to the other one, splitting it into quarters. So the same shape, split into 4. So 3/4, we've got 1, 2, 3. So that's 3/4, and this is 1/4. So you can clearly see that 3/4 is larger than 1/4. All right, so just make sure that when the denominators are the same, the larger fraction depends on what the numerator is. So this one, it's 3, so it is going to be 3/4 is your largest fraction. Now 3/8 and 4/7, so you could change your denominator. All right, so you would have to change it to 8 times 7, which is 56. But I think one like this, it's probably better to think about where they would fit on a number line. So all proper fractions go from 0 to 1. All right, and we know half is in the middle. Now 3/8 is less than a half, because if I write a half as a fraction over 8, it's 4/8. All right, and 3/8 is clearly smaller. So we're going to be on this side of the half. And then for 4/7, well, because we've got an odd number on the bottom, we wouldn't usually write a decimal in a fraction. It's not good maths. But just to compare, we can clearly see that 4/7 is going to be bigger than a half. It's going to be on this side. All right, so if you can kind of think whether they're greater or smaller than a half, or whether they're closer to 0 or closer to 1, it does help you make that comparison without having to change your denominators. All right, so for this one, our larger fraction was 4/7. All right, so we can use this same concept for the next one, but you can see that they're both going to be greater than a half. All right, so we've got 8/13 and 6/11. Now, 6/11 is pretty close to 5.5/11, not far off it. Whereas if we're doing 13 as a fraction, we would do 6.5. All right, they're both odd numbers, so we don't tend to simplify them like this with the decimal, but for this purpose, it does help us compare. So 6.5/13 is the same as 5.5/11. They're both equal to a half. Oh, sorry. Sorry. I just got a little bit mixed up. So they're both equal to a half. So you can see that 6/11 is closer to 5.5 than 8/13 is the same as 6. Then 8 is closer. Sorry. Let me start again. So 6 is closer to 5.5 than what 8 is to 6.5. So your larger fraction would be the 8/13. Now let's say that concept was a little bit tricky to understand. Then we just have to change the denominators. All right, so let's just go ahead and do that. So to make the denominators the same, you can just multiply. So 13 times 11. Now, this should be on your multiplication table. So I know that 12 times 11 is 132. So I'm going to add another 11. So we should get 143. All right, and what did I do to the top here? I multiplied it by 11, so that's going to be 88/143. So let me just do that. And then for this one, we multiplied it by 13. All right, so 6 times 13 is 78. Yep. All right, so we can see that comparison there. So 88/143. Is bigger than 78/143. And you can see multiplying those denominators does make that comparison a bit easier, but you can also think about where they fit on a number line like I did before. All right, and I was doing those multiplications in my head. You will have your multiplication table, which makes it a little bit easier. All right, 5/12 and 3/7. So here, again, we're pretty close to a half, so both of them are just under a half. All right, so 5/12, if we were writing half with the denominator of 12, it would be 6/12, and then comparing that to 3.5/7. So they're both equal to a half, and we can see that 3 is closer to 3.5, but again, I'm kind of thinking, I would be a lot more comfortable if I changed the denominator. So let's go ahead and just change the denominators. All right, so changing them, remember we're just making a comparison here. So it doesn't matter what your denominator is. It doesn't have to be the lowest common denominator. So I can do 12 times 7, which is 84. All right, and then what did I multiply the 12 by to get to 84? I multiplied it by 7, so that means my top is 35. And then I multiplied the 7 by 8. All right, so we can see that my rationale before was actually incorrect. All right, so it was a good thing that I went ahead and checked that. So 5 over 12 is the same as 35 over 84, and 3 over 7 is the same as 24 over 84, making 5/12 the bigger fraction. All right, so question number 5 is a bit of a tricky one, because if you're looking at 3 fractions that are between 1/4 and 5/8, it's hard to think of what is between them unless you had the same denominator. So we've got 1/4 and 5/8, so let's make the denominators the same. All right, so I know that 4 goes into 8, so let's change that 1/4 to be a fraction over 8. So I multiplied the 4 by 2, so that means I've got to do the same to the top. So 2/8 is the same as 1/4, and we're going to look at fractions that are between 2/8 and 5/8. Now you could just do 8s if you wanted to. So we've got 3/8 and 4/8, but I need to find 3 fractions and I've only currently got 2 of them. So I need to think of, okay, what's another fraction in between? So this is where you can change your denominator again. So if I went ahead and changed my denominator, and I'm going to do it in green just so we can see the difference. So I'm going to change this denominator to 16. All right, so that means it's going to be 4 over 16. And then my 5 is going to be 10 over 16. So looking at 3 fractions in between, I could keep my 3/8 and my 4/8 as 2 possible fractions. But then anything else in between 4 over 16 and 10 over 16 is also possible. So I could do 9 over 16, let's say. All right, so those 3 fractions are all between 1/4 and 5/8. You can just change your denominator to make it a little bit easier for you. All right, let's have a look at question number 6. So putting the following fractions in ascending order. So the word ascending means from smallest to largest. All right, so when we're comparing fractions, again, it's easier to do if you've got the same denominator. So we can see with these fractions here, we have different denominators. Now, you could think about where they would fit on a number line, which could make it a lot quicker. All right, so if we were to place these on a number line with 0 here and 1 here, let's see how we go. And we've got a half in the middle. All right, so 3/4 I know is bigger than a half, and I actually know it's here. So there's 3/4. All right, so it's halfway between a half and 1, or 3/4 of a way along. Now 1/6 is quite a small fraction, so it's probably down here somewhere. There's 1/6. All right, 5/8 is just going to be just over a half, because 4/8 is a half. So I'm going to put 4/8, sorry, not 4/8, 5/8. Yeah. And then 3/8 is less than a half, so I'm going to put 3/8 here. And then 5/12. So 5/12 I know is also less than a half, but I'm not really sure how it compares with 3/8. So I might just on the side here compare 3/8 and 5/12. All right, because I'm not entirely sure where they fit. So I need to have a common denominator. All right, and doing 8 times 12 is possible, but I also know they both go into 24. So finding the lowest common denominator. All right, so I multiplied the 8 by 3, so I do the same to the top. And then for the 12, I multiplied that by 2. So I'm going to have 10 over 24. So 5/12 is actually larger. So it's going to be somewhere in here. I might just write it up the top. So if I'm putting them in order, I've got 1/6 and then 3/8 and then 5/12, then 5/8 and then 3/4. So that's how you could do it on a number line. All right, so I'm just going to delete all this. All right, so question number 7, this time we're doing it in descending order. So that means going the other way. So from largest, to smallest. And again, you could use your number line if you like, but I'm going to do this one slightly differently. I'm going to have the same denominators. So I'm going to write each fraction with a denominator of 20 because all these denominators go into 20. All right, they're all factors of 20. All right, so let me just do this in a different color. I'll do it in green. All right, so what did I multiply the 4 by to get to 20? I multiplied it by 5. Then the 5 I multiplied by 4. The 10 I multiplied by 2. So you'll notice whatever I'm doing to the bottom, I'm doing to the top of the same fraction, and then the last one's the same. All right, so 1/4 is the same as 5/20. 4/5 is the same as 16/20. 3/10 is the same as 6/20. 1/2 is the same as 10/20, and 13/20 on the end. All right, so putting them in order. So I'll need to write their original fraction because we want to keep them in simplest form. All right, so the smallest one is the 5/20, which is 1/4. Then we have 6/20, which was 3/10. Then we had 1/2. Then 13 over 20. Oh, yep. Sorry, I thought I didn't simplify that then. And then the next one is 4/5. All right, so just rewriting them as they were originally in their simplest form. All right, so moving on to the second success criteria. So can convert mixed numbers and improper fractions. All right, so remember that 6/4 is the same as 6 divided by 4. So as you move through maths in secondary school, you won't use the division symbol anymore. You'll be using fractions. So we don't usually write 6 divided by 4. We write 6/4. So this is basically saying how many times does 4 go into 6? It goes in once. And what's our remainder? It is 2. So we write 2/4. So the same denominator. All right, and that simplifies to 1 and 1/2. All right, moving on to question B. So how many times does 3 go into 16? Goes in 5 times. Remainder 1. So we're doing 1 over our denominator, which was 3. 29/5. So 5 goes into 29 5 times. Our remainder is 4. So it's 5 and 4/5. And then 6 goes into 46 times with a remainder of 4. And we can simplify that to 6 and 2/3. All right, now going the other way, all right, we're pretty much doing the same thing, but backwards. All right, so we can think of this number 3 is the same as if we're writing it as a denominator of 5. It's the same as 15/5. So effectively what we're going to do here is 15/5, which is our 3, plus 2/5 gives us 17/5. Now separating it like that can be quite lengthy, and there's nothing wrong with doing that. It actually shows a bit of understanding of what you're doing. But just to make things a little bit more streamlined, we're going to do it a quicker way. All right, so our denominator stays the same, so it's still 5, and we don't need to simplify it. We're only writing it as a improper fraction. So an improper fraction is just having your numerator bigger than your denominator. All right, so we go 3 times 5 and then add the top number, your numerator. So 3 times 5, I might just write it here, 3 times 5 plus 2. So 3 times 5 is 15 plus 2 is 17, so 17 over 5. All right, so looking at question B, we keep the denominator the same. So it's going to be 4 times 7 plus 4. All right, bit annoying that we've got 2 4s there, but hopefully you can see 4 times 7 plus 4. So 4 times 7 is 28 plus 4 is 32. All right, so it's 32 over 7. We keep the denominator the same. All right, the next one, 5 times 8 is 40 plus 3 is 43. And then the last one, 6 times 9 is 54 plus 8 is 54 plus 8 is 62. All right, moving along. All right, adding fractions. So remember, when you're adding fractions, you have to have the same denominators. All right, you will find it very difficult to add if you didn't have the same denominators. I don't want to say you can't do it, because I'm pretty sure there are plenty of people out there who can do it quite easily in their heads. But just to make it a little bit more straightforward, it's better to have the same denominators. Now, you only need the same denominators when you're adding and subtracting, not multiplying and dividing. All right, if you're changing the denominators for multiplying and dividing, you're adding an extra step that is not required. Okay, so only when adding and subtracting do you need to have the same denominators. All right, so our denominators are the same here, which is good, so we don't have to change them. So that means my answer is over 5. Actually, let me write the answer to the side. Oh no, I'll write it underneath. Sorry, I'm just thinking about the space I'm going to need. All right, so over 5, and then we just add our numerators together. All right, so we keep the denominator the same, and we add our numerators. So 1/5 plus 2/5 gives me 3/5. All right, looking at question D, we have different denominators. All right, so we do need to change these fractions, and you can change them hopefully to the simplest. So having the lowest common denominator, not the simplest fraction though, but the simplest denominator, the lowest denominator, which is 15. All right, if you're ever unsure, just multiply your denominators together, 3 times 5, and often you get the lowest one, but not always. Okay, so what did I do to the 3 to get to 15? I multiplied it by 5, so I have to do the same to the top. So 1/3 is the same as 5/15, and then I've got to do the same to the other one. So 2/5 is the same as 6/15. All right, adding them together, remember your denominator stays the same, and then we have 5 plus 6 on the top, which is 11. All right, question G, we have a mixed number. Now, this one is a little bit easier than other mixed number ones because we don't have to change the fraction to an improper fraction. And the reason for that is because when I add these fractions together, I'm not going to get an improper fraction. So what I can say is, all right, let's multiply our whole numbers together. So 2 plus 1, and then let's add our fractions together. So 2 plus 1 is 3, and then adding our fraction parts is 3/5. All right, so 3 and 3/5. You could change them to improper fractions, but if you did do that, then you've got to go back and put them as a mixed number, which can be quite time consuming. So just separating them. All right, question J. We got 2 and 9/10 and 5 and 3/5. So I do have to change the denominators to be the same. So I'm going to change them to both be over 10. So the first one I don't need to change because it's already over 10. And I'm only changing the fraction part. So I multiplied that by 2 and that by 2. So 2 and 9/10 plus 5 and 6/10. Now at this point, I know I'm going to get an improper fraction if I add my fractions together. So you can do that, and maybe I'll do that and then I'll show you converting it to an improper fraction, and you can decide which method you prefer. I think it's better to change to an improper fraction, but you can keep them like this if you like, and not change the fractions to an improper. All right, so we've got 2 plus 5 plus 9 tenths plus 6 tenths. So I get 7 and 15 tenths. All right, and we can't leave that fraction there because it is actually an improper fraction. So I can say, oh, that is the same as 15 over 10. 10 goes into 15 once, and then we've got 5 tenths remaining. So 7 plus 1 is 8. And just because I'm running out of room, I know that 5 tenths is a half. So we get 8 and a half. All right, so you can see what I've done there in adding these two fractions together. I get an improper fraction, but I can still deal with that. I can convert it to a mixed number and then add it together like I've done so there. All right, so perhaps jot that method down and then I'll show you the other method. So if you want to pause, please do before I rub it out. All right, so you could also change it to an improper fraction and then add them together. So I probably didn't need to delete that first line. So let's put them back as fractions over 10. All right, so changing the first fraction to an improper fraction, so our denominator stays as 10. 2 times 10 plus 9 is 29. And then 5 times 10 is 50, so 56. So I get, what is that, 85 over 10. And then I say, well, how many times does 10 go into 85? That is 8, remainder 5, so 5 over 10, and you can get your 8 and a half that way. All right, so you could choose either method. I do prefer this method that I've done, just because I'm a bigger fan of improper fractions, because you do see them more than mixed numbers later on in maths. But mixed numbers do mean more than improper fractions. So understanding 8 and a half is better than saying 85 over 10. All right. Have a go at doing the other questions here. So I'm going to pause it and do the answers. I hope you do so too, so you can have a go and then check your answers. All right, so there's the answers. I can't remember where I stopped. So there's the middle section. So if you need to just quickly pause. All right, and then the last ones. So hopefully they're all correct. It's a bit late and getting tired, but yeah, please let me know if there are any errors. All right, moving on to the success criteria for number 4, which is subtracting fractions. So adding and subtracting are pretty much buddies. Same thing, you need to have the same denominator. So you can see with question A, we've got the same denominator, which is 5. So 4 minus 2 is 3. So 4/5 minus 2/5 gives you 3/5. Always think if you can simplify as well. All right, question D, changing your denominators. So again, it's going to be over 15. So multiplying the 3 by 5 to get that 15. So we do the same to the top. And then we multiplied the 5 by 3. So we do that to the top. All right, so 10 over 15 minus 3 over 15 is 7 over 15. Now with question G, we can't really split it up because we're going to have a smaller fraction taking away a larger fraction. So you kind of have to borrow. So I'm going to show you this 2 ways. All right, one way that we've been doing it in class, but a way that you can also borrow. So I'll show you the borrowing way first because I want to keep the other way on the solution. All right, so if we want to, we can actually borrow from the 2. So 5/5 is the same as 1. So I just need to add 5 to here. So, all right, so 1 and 6/5 is the same as 2 and 1/5. And then I can minus the 1 and 2/5. And then I can do my 1 minus 1. All right, so we've got the 1 minus the 1. and then the 6/5 minus the 2/5. So 1 minus 1 is 0, 6/5 minus 2/5 is 3/5. All right, so that's how you can use borrowing if you like. But if that was a little bit too confusing, then just change them to improper fractions. So we're going to do that. All right. Oh, it's not going to let me delete it. There we go. All right, and I'm not saying there's anything wrong with that method. It's just I think some of you might have a little bit of trouble understanding it. So let's convert it to an improper fraction. All right, so improper fraction, keep the denominator the same. So 2 times 5 plus 1 is 11. And 1 times 5 plus 2 is 7. So keeping your denominator the same, so 11 minus 7 is 4. So we can get our 4/5 that way as well. All right, moving on to J. So we need to have the same denominators. So we don't have the same denominators here. So let's change it. So we've got 2 and 9/10 minus, so that's going to become 6/10. Now for this one, I don't need to change it to an improper fraction because I can see the second fraction is actually smaller. So I can do 9/10 minus 6/10, which is just 2 and 3/10. So changing it to an improper fraction is fine. It's just an extra step that's not really needed. All right, so let's see if there's any tricky ones here that I might need to do. Okay, have a go at doing these on your own, and then so pause, and then you can unpause to get my solutions. All right, so just looking at the solutions here. So there's the solutions for that middle row. Excuse me. So the last one, K, I was doing it and I was like, oh, it probably is easier to do borrowing, but you've got your multiplication grid, so those numbers shouldn't be too tricky. And then moving on to C, questions I, what are you doing down there? Let's put you back up. I and L. Just having to change the denominators for both of them, but then it didn't become too tricky. And then for L, you did have to then simplify 2 and 3/6 to be 2.5. All right. Success criteria number 5, that you can multiply fractions. So multiplying fractions, I think out of adding, subtracting, and dividing is the easiest. Now it's the easiest because you don't need to change them at all, unless they're a mixed number. As long as they're a proper fraction or even an improper fraction, you can multiply them. If they're a mixed number, just change it to an improper fraction and then do your multiplying. The reason it's easy is because we just multiply the top numbers, so our numerators, so 1 times 1, and then multiply our denominators, so 2 times 5. So it just becomes 1/10. Now, when you're multiplying numbers, the order doesn't actually matter. So sometimes it can be easier to switch your numerators. So we've got 2/3 times 1/2. That is actually the same as 1/3 times 2/2. So all I've done, it's a bit too thick, that one. All I've done is I've switched my numerators. And that is a very good thing to know, because sometimes we come across numbers that are hard to multiply. So switching your numerators just makes it a lot more easier. I should just say a lot easier. All right, so 2/2 is the same as 1. So we've got 1/3 times 1, which is just 1/3. Oh, I wish I would stop doing that. There we go. All right, so just 1/3. Now, let's say I forgot to do that, because this question is actually not that difficult to do. So we can just still go ahead and multiply our numerators and our denominators. So we could do, let me just get rid of that green. We could do on our top 2 times 1, and then on the bottom 3 times 2, and I get 2/6. And we know that that simplifies to 1/3. So you can get your 1/3 that way. And this one is not too difficult because you've got small numbers to multiply. but we'll do some other ones later where it is probably a good idea to switch them over. All right, so for question G, we've got mixed numbers, just changing them to improper fractions. So 1.5 becomes 1 times 2 plus 1, which is 3. And then 1 2/5 becomes 1 times 5 plus 2, which is 7. Now multiplying your numerators, so 3 times 7 over your denominators, 2 times 5. So 3 times 7 is 21, 2 times 5 is 10. Now we should write our final answer as a mixed number. So 10 goes into 21 twice with 1 remainder, so 2 1/10. All right, so you do need to convert them to an improper fraction first. All right, question J is one where it's probably a good idea to switch your numerators because you can multiply it, but then you're going to have to simplify. So if I switch my numerators, instead of the 5, I'm going to have 3 over 6. And then instead of 3 over 5, I'm going to have 5 over 5. All right, so I'm just switching over my numerators. Now, before I knew that 5 over 5 was 1, and I also know that 3 over 6 is 1/2. So I'm basically doing 1/2 times 1. So our answer is 1/2. All right, so question B, again, you can switch your numerators. So you're not going to be able to switch them for everyone, or you're probably not going to want to, but just if you ever get stuck, just switch them over. So I'm going to have 1 over 11 times 4 over 8. And 4 over 8 simplifies to 1/2. So I'm going to multiply my numerators and multiply my denominators. So I get 1 over 22. Now, if I didn't do that, I might just do it in green and then rub it out. I would have to do 4 times 1 over 11 times 8, which is 4 over 88. And then you're going to have to simplify that. So you could still get the 1 over 22 that way, but the other way is just simplifying at the start as opposed to the end. All right, so 3 over 8 times 2 over 9. So here's a good example of switching them. So I'm just going to switch the 2 and the 3. So 2/8 is the same as 1/4, and 3/9 is the same as 1/3. So multiplying my numerators and multiplying my denominators, I get 1/12. All right, so you can see simplifying at the start is probably a lot better. So for this one, you would have had to do 8 times 9, and I know you've got your multiplication table, but then you're going to have to simplify that. So just switching those denominators and simplifying at the start just makes multiplying fractions a lot easier. All right, so question H, we've got another mixed number. So let's quickly do that. Your denominator stays the same. 3 times 2 plus 1 is 7. And then we've got 1 times 7 plus 2 is 9. All right, notice that I haven't been changing my denominators. You do not have to have the same denominator when you're multiplying, which is great. All right, so for this one, I can see switching my numerators makes this so much easier. All right, because I end up with that 7 over 7, which is just 1. So I could just say, all right, that's 9 over 2. And I do need to write my fraction as a mixed number. So 2 goes into 9 4 times with 1 remainder, so 4.5. All right, let's just have a look at K. So converting it to an improper fraction. So 2 times 12 plus 1 gives me 25. And then 3 times 3 plus 2 is 11. Now here's one where, I can't actually simplify it, because switching them is actually not going to make it any easier for me, unfortunately. So I just want to make sure that I've done that correctly. All right, so I am going to have to do 25 times 11. Now I know that 25 times 10 is 250. So basically I'm doing 250 plus 11. So just using some mental strategies there. And 12 times 3 is 36. So we end up with 261 over 36, and this might be a little bit tricky to do. So you wouldn't have one of these on your test because it's a little bit too high. Let me just think though. So 36, 72, 144, 174, 180, 180, then 152, I think, 150, no, 252. So that was 7, and, oh, what is that, 9? 9 over 36, which is 7 and, oh my gosh, where's my, so 1/4. All right, that one I'm going to have to check. Let me just quickly check that one. Just because doing that 261 divided by 36 is quite a big thing. Okay, so I've made a mistake somewhere along the line. I did my wrong. That should be, I did that one wrong. Okay. So, and I did this one wrong. Oh, I added the wrong thing. Okay. So it was 250. I added 11. I should have added 25. That's what I did wrong. There we go. So that gives us 23 over 36. All right. So again, you're not going to have something that high on your test. All right, but it's still a good challenge. All right, so perhaps pause now and do that last row on your own. All right, some high numbers there, especially with question I and L. Just want to look at question C because I thought it was quite an interesting one. So let me just highlight. So we've got 9 over 10 times 2/3. So I knew to change the numerators just to make it a little bit easier. So we had 2 10s over 9/3. Now 2 10s becomes 1/5, which is here, and 9 over 3 is, so 9 divided by 3 is 3. Now this is what I want to show you. So basically if we're multiplying by a whole number, all right, that is the same as saying 3 over 1. So we can convert any whole number into a fraction by just putting it over 1. So I've got on my top 1 times 3 and the bottom 3 times 1. So getting the 3/5 that way. All right, let's move on. Okay, so moving on to division. Now division and multiplication basically go hand in hand. So dividing by a fraction is the same as multiplying by its reciprocal. So what I mean by a reciprocal is just flipping the second fraction. All right, that's what a reciprocal is. You are just flipping the fraction. Now, the phrase we use to remember how to do division is keep, change, flip. And all that means is we keep our first fraction as it is, so 1/5. We change the division sign to a multiplication sign, and we flip the second fraction. And the reason I use the word reciprocal is because multiplying by the reciprocal is the same as dividing by that fraction. All right, so now that we've got a multiplication there, we can go ahead and do that. Now I can switch my 5s. I can see I can do 5 over 5 times 1/2. All right, and then I'm going to end up with a half. So if you can do multiplication, you can also do division. And as I said before, multiplication I think is the easiest because you don't have to change your numerators. Our denominators. We don't have to change our denominators for this either. All right, the only thing that might need changing is if we have a mixed number. All right, so let's move on to the next one. So remember, we keep the first fraction as it is. We change the division sign to a multiplication sign and we flip. So 1 over 4 is the reciprocal is 4 over 1. All right, changing them is not going to make any difference. So my top is going to be just 2 times 4 and my bottom is going to be 3 times 1. So 2 times 4 is 8 and then 3. Now it is an improper fraction, so let's just convert it to a mixed number. So 3 goes into 8 twice with 2 remaining. So 2 2/3. All right, so for the next one, we do have one mixed number. So let's change that to an improper fraction. So remember, the 5 stays on the bottom. So 3 times 5 plus 1. So that gives me 16. And then we're going to, oops, let's just do it in one go. So, oh, come on. Sometimes oh, yeah, you decide to work now. All right, so we're going to keep change flip. So I'm going to keep that first fraction, same fraction, just is written as an improper fraction now. We change our division sign to a multiply, and then we flip. All right, so 16 over 5 times 5 over 2. And I can see that changing my numerators is going to make life a lot easier for me. So 5 divided by 5 is 1. And 16 divided by 2 is 8. So my answer is actually just 8, a whole number, not even a fraction. All right, question J. So again, changing that mixed number. So we keep the denominator as 5. 2 times 5 plus 2 is 12. Then we change the division to a multiply and then flip. And I can see again, changing my numerators just makes it a lot easier, and we're going to end up with a whole number again. What is that? 4. And that's because our denominators were the same for this one. All right, and the previous one. Okay, so looking at question B, let's do one more, and then we might, actually I might do the last, so I'm in the last row. Okay, so for C, we've got 1/2 divided by 1/4. So we keep, we change, and we flip. Now, we don't need to swap our numerators. You can see this is quite an easy one to do. So we could have 1 times 4 times 2 times 1. So that gives me 4 over 2, which is 2. Now, if I had a whole number like I do in F, 4 is the same as 4 over 1. So remember, any whole number can be written as a fraction. All right, it's an improper fraction. So 7 over 8, keep, change your division to a divide, and then we're going to flip that 4 over 1 to become 1 over 4. Now, changing my numerators is not going to make any difference, so let's just multiply them. So we've got 7 over 32. All right, let's have a go at the next one. So we've got 5 over 6. And I could probably do this in one go. So the flipping of the 2 becomes a half. Changing my numerators isn't going to make any difference. So let's just do 5 times 1, 6 times 2. So I end up with 5 over 12. All right, so pause it there. Have a go at doing L on your own and those middle questions as well. And then you can check back on your answers. Bye. All right, so a lot of these, you can do your multiplication in your head. So you can see I may have missed some steps, and that's just because you can do the multiplication in your head, or you can write it down and then do the multiplication. So there's the middle row, and I'll just scroll down so you can have see the answer to L. Right, so there it is. Oh, 14 over 9. I didn't write it as an improper fraction. Let's just fix that up. Not an improper fraction, a mixed number, I should say. So 14 over 9 is the same as 1 5/9. All right. Last success criteria is worded problems. So we've got 2 questions here. Perhaps have a go at doing them if you like before me listening to me. I am going to go through both of them though, but have a go maybe and then you can watch and see how you went. All right, Sarah is organising ingredients to bake a cake. She has 8/12 cup of flour, 8/9 cups of sugar and 4/10 cups of butter. Before using these ingredients, Sarah decides to simplify the fractions. Simplify the fractions. All right, so for flour, we have 8/12. So we just need to simplify that. So whatever, I need to find the highest common factor, and whatever I do to the top, I've got to do to the bottom. So the highest common factor is 4. So 8/12 is the same as 2/3. Then what do we have? Sugar. So I've got 6/9. So the highest common factor is 3. So we're going to divide the top and the bottom by 3. So we've got 2/3. And then what's left? Butter. So we've got 4/10. So the highest common factor is 2. So we're going to divide the top and the bottom by 2. So we get 2/5. All right, question B. Let me just scroll down. For one of her cake recipes, Sarah needs to combine several ingredients. She needs 2/5 cups of milk and 3/10 cups of cream. How many cups of liquid does she need? All right, so we're going to add them together. Now you'll notice that we don't have the same denominator, so I need to rewrite them with the same denominator. So looking for the lowest common denominator, which is 10. All right, so just going to make them both over 10. And then we can see the first one has to be changed, so I'm going to multiply that by 2 and that by 2. So 2/5 is the same as 4/10, and the second one doesn't need to change. So she's got 7/10 in total. All right, she's also making a salad that requires 5/8 cups of oil. After pouring 3/8 cups of olive oil into the salad, she realizes she needs more. Hasn't quite made it to the 5/8. How much more does she need? All right, so 5/8 minus 3/8. She needs 2/8 of a cup more, and we need to simplify that because that is not the simplest form. So 1/4 to go. So making sure you always write your answer in the simplest form. Sarah decides to make a double batch of cookies. Their original recipe calls for 2 3/4 cups of chocolate chips. How many cups of chocolate chips does she need for a double? So double means 2 multiplied by 2. So we're going to have 2 3/4 times 2. Now we do need to convert that mixed number to an improper fraction. So 2 times 4 plus 3 is 11. And then remember 2 can be written as 2/1. Now you can switch your numerators, might make it slightly easier. All right, so we're going to have 1/2 times 11/1. So that gives me 11/2, which is 5.5. So she needs 5.5 cups. All right. Sarah has 5/6 cups of lemon juice, but needs to divide evenly among 3 glasses for lemonade. So she's got 5/6. We need to divide it amongst 3. All right, so remember we do keep, change, flip. So we're going to keep, change, and then flip that 3 to 1/3. So multiplying your numerators, so 5 times 1 is 5, and then multiplying your numerators. So 6 times 3 is 18. So each glass of lemonade receives 5/18 of lemon juice. I don't know about you, but when I cook, I don't measure. So poor Sarah, obviously wants to have all these correct measurements. I just, would pour anything in or bake a cake and not really just go by consistency more than accurate measurements. All right, last question. Emma is planning a community garden project and needs to distribute seeds and resources among different plots and volunteers. Emma has 15/20 of a plot allocated for planting flowers. Simplify this fraction. So 15/20, looking for the highest common factor. So factors of 15, right? You can do them on the side. The highest is going to be 5. So 15 divided by 5 is 3. 20 divided by 5 is 4. So 15/20 is the same as 3/4. For watering the garden, Emma needs 3.5 litres of water per plot. Convert this mixed number to an improper fraction. So 3.5, we just need to keep our denominator the same. So 3 times 2 plus 1 is 7. So 7/2 is an improper fraction. All right, hopefully that's 7 moves. There we go. Emma has 5/6 kilograms of compost and needs to divide it. Oh, did we just do this question before? Or was it a different? Feel like the fractions are the same, different questions. Where are we? It is the same. Oh well, let's do it anyway. Divided by 3. All right, so remember we keep, we change, and we flip, guys. So that's where we're going to get 5/18. All right, and is this the last question? No, got a few more to go. Emma needs to combine 2 different areas of land for planting vegetables. The first area is 2/3 a hectare and the second is 1/4. How much land? So we've got to add them together. So 2/3 plus 1/4. And we can see that they're not the same denominators. So when we're adding, we need to have the same denominators. So we're going to add 2 fractions with the same denominator, which is 12. So I multiplied that 3 by 4, so I've got to do the same to the top. And then the 4 I multiply by 3. All right, so I get 11/12. Emma poured out 7/8 litres of fertilizer but only used half a litre. How much fertilizer does she have left? So 7/8 minus a half. Now we need to have, because we're subtracting, we need to have the same denominator. All right, so just changing that half to 4/8. All right, you can pause at any time if I'm going too quickly. I'm just conscious of the length of the video. Each volunteer needs 2/5 of a kilogram of seeds. Emma has 4 volunteers. How many kilograms of seeds does she need in total? So we're going to multiply it because we need 4 lots. All right, and remember any whole number can change into a fraction just by putting it over 1. So 2 times 4 is 8 and 5 times 1 is 5. So that is an improper fraction. Let's put it as a mixed number. So she needs 1 3/5 kilograms. All right, guys, end of the revision. Well done if you got that far. Good luck. Bye.